just going, I mean, I saw some queues over the mountain, so. Yeah.
Okay. You know what they say, right? Time flies like an arrow, and fruit flies like a banana.
Right.
No? Okay. I won't quit my day job, Josh. All right. So, well, we're moving into the afternoon and sort of changing pace a little bit to some. You might be excited about that. So with us this afternoon, anyway, we're going to talk a little bit about geospatial data sharing and the big weather web. And our first speaker, Carol Song out of Purdue University, is the lead for a TerraGrid Purdue Resource Partner Project there, the PI. And she also leads the Scientific Solutions Group at the Rosen Center for Advanced Computing at Purdue. She has an absolutely fascinating, great work history in scientific computing, which spans the medical and health industry, and was a research programmer at the National Center for Supercomputing Applications. And without further ado, I introduce Carol Song. Thank you very much.
Thank you, Steve. I'm very glad to be here. Thanks for the invitation of the committee. I am thankful for this opportunity to talk about some work we have done related to this project. And oops, I need to get this thing started. Okay, so this morning I heard the summary of the previous day's presentation, so I really am taking to heart this principle of less is more. So since this is after lunch, and I don't know how alert you are, and so I'm going to try to be, I try my best to be entertaining. Before I talk about some of the details with the project, I think my presentation will be very different from the previous presentations, that I'm less structured, especially with the hands-on portion. I'd like people to get a feel of what we're doing, get on our website to try some things. But, you know, for all your overachievers, you're going to get the sense of satisfaction by doing some simple things. So I'd like to start by telling a story about Steve. I just got to know him, I guess, a couple of weeks ago, and I think we were beginning a really, I hope, a nice collaboration. So there's Steve, a picture I stole on the internet. So here's a picture he sent to me that at first he was telling me he's out of Melbourne. I thought it was Australia, so he sent me some data. I plotted, and it was not in Australia at all. So, and so here's one of the data set that he sent to me. It's a spreadsheet with about 12,000 data points. And it's not big data in size, but still to be able to make some sense out of it for somebody who didn't generate the data, probably it's not totally trivial. So we did something really quick. So we showed his data. We just imported his data to some of our tools, and so you can see the path he was going. I really like his job. I think, you know, I'm a computer scientist by training. I don't go out. I sit there all the time inside my office, and while he's out there having fun going on a pontoon boat. And we did some quick poking into his data. In this particular data, we select all the data points, all 12,000 data points, and then did this plot. And I think it's wind speed that he was measuring. And you can get the sense as he was going around the river, that's what he gets. I don't know if he's aware of that, but I hope that helps. And also we zoomed in on one part and see, well, the GPS coordinates, we don't totally understand what those are, but there seem to be small variations, and we will try to understand better. But we have this view of side by side, and so the best part of this is that Steve sent me. He was out there on June 4th collecting this data, and he emailed me his spreadsheet, and I imported the data. Basically, in no time, I got some of the printouts of which you saw. Now, I'm cheating a little bit. So what you're seeing with this graphics is really what we're going to push out in the next version. The current version that we have installed is less capable. It doesn't have this real map being for people to be able to zoom in and out. So I'm showing this more in advance, but I'm really excited about how quickly we can get this up without any programming. So this is probably kind of a really nice lead into what I'll talk about, the goal of our project. So the work I'm going to represent a lot of hard work by a lot of people. We have a large team of people, including our science domain experts from hydrology and social science, and also our developers, our students, and it's a big team. And so what I like to do with a little bit of structure is I like to kind of give an overview of what we're doing with this project we call GAPS, and talk about our development, and especially want to mention how we're engaging various communities to make this more useful and be truly driven by community needs. And I have a little bit of a hands-on going with the tradition of this workshop and see how that goes. And what we really like to hear is your feedback. Now, I'd like to point out two of the team members are here, Lan Zhao and Rajesh. You want to raise your hand? So while you're doing your hands-on or have any questions, feel free to ask me or go to them. Okay, so So this project really started when we realized that a lot of work we do have to do with putting data in the context of maps and dealing with geospatial data. I thought this workshop report really summarized the trend very nicely. So this 2012 workshop on spatial computing, one of the tables I stole from the report. So you can see on the left-hand side that it lists all these issues with geospatial data. Basically, it says, really you have to be highly trained, you have to understand these special software packages, how to use them, and some of them can be very complicated. Nowadays, though, really geospatial data is everywhere. Everybody carries GPS-capable phones or devices, and we're seeing data being collected everywhere, and all the platforms seem to be location aware. So the need for somehow viewing these data, using these data by a lot of people in a very easy way, that's really what we're seeing. And so it's really consistent with some of the work we've been asked to do. For example, viewing data but in the context of maps, and allow people to select data and visualize them. And when people share data, they don't just, somebody used the loading dock scenario. I thought that was a very good description. You don't want to just dump them there with binaries or whatever format. You want people to be able to see them. And then you have data from multiple sources. This is one example that we have drought maps overlaid with crop information, I think, land use and crop information. And be able to give different characterization of the impact of droughts. And of course, we also worked with global scale economics data. And so all of that coupled with some of the technologies that we were working with. I don't know how many people have heard the HubZero or used it. Not very many. Okay. So HubZero really is a web platform specifically designed for scientific collaboration, data sharing, tool sharing, cloud computing, all of that good stuff packaged in one. And originally it started with a nanotechnology society or domain where people want to do online engineering simulations. And so this gives people the capability to do remote visualization interactively. And later, the HubZero team has done more with data publishing, and now it's evolved into classroom teaching and online MOOC type of classes. And it started at Purdue and being developed by Purdue. And so as this technology become more and more mature, and we have done some of this work on this platform, and we felt that this is a direction to go. And also we're working with many other existing third-party software technologies and packages, which I'll mention a little bit more later. So our goal really, we call it GAPS, so it's geospatial data analysis building blocks. It's a proposal to the NSF new data program called Data Infrastructure Building Blocks. So our goal is really to lower the barrier, allow people to easily put up tools, put up geospatial data to share with the world. And the impact that comes with it would be, we're hoping to really broaden the user base of geospatial spatial computing, geospatial data sharing, and all of that. And it also would help people to disseminate research results. So again, you don't just put a big zip file up there for people to download and try to make sense out of the data that they didn't generate themselves. And also to share, to be able to link data sets with their publications. And all those things are people repeatedly ask for. And also to put everything on the web, no software download, no configuration issues. All you need is a web browser. That type of tools are really conducive to use in classrooms. So the instructors, many of you, just like many of you, you don't need to mess with software installs and assigning accounts and all of those things. And we're seeing a lot of interest in that area as well. So to talk a little bit about HubZero, so you know, since all our software in this project are built for HubZero, so it would provide some context. So if you look at HubZero, it really is built on a lot of open source software with PHP, MySQL as the database, and underneath it's the Joomla framework for content management and all these stuff that you're familiar with. So it's basically a web server, and then users interact with the site built with HubZero through their browser. Now, there's a lot more, and to support the execution of your tools. So it could be a tool that just runs on what we call execution hosts, which just, you know, sort of horizontal scaling of your web server specifically for computation. And all these sites can be connected to run computation on remote resources, all kinds of resources, including the national, some of you may be aware, EXCEED, supercomputing systems, and cloud like Amazon or other clouds, things like that. And each of the tools runs within a container, OpenVZ container, so it provides security, privacy of data, and all of those good things that you want to have. And also it has, so a lot of people, I'm not sure within this community, I know you guys are all experts with Python. You can write all kinds of scripts, libraries, but how many of you feel comfortable to do web programming? And that's, okay, I see one hand, great. And so to help people who don't want to or don't like to do web programming but still want to share their tools online, and there's a rapid development, tool development library toolkit that people can use. It's in the form of different, it has APIs for different languages that you can build into your code, or you can write a wrapper around your black box code if that's what you want to do. So basically, you don't need to do any web programming in order to put your tools up on the web. Just give you a sense of who are using. So different communities have used HubZero for building their community websites, or you can call them science gateways. These are typically portals to some scientific codes that runs behind the scene. So there are some user numbers, and you can see that some sites attract more people. Like NanoHub is really the grandfather of all the hubs. And we're starting a new hub that's dedicated for geospatial computation and data sharing. And we had these numbers, I think, last December. And I just checked yesterday and seemed to have gone up quite a bit. Although I was told in May we got some spammer attacks. So some of them could be those. We're going to get rid of those ones. A few words on the overall architecture of what we're building. So you can see that on the bottom there's already a bunch of things that are built into HubZero already to support collaboration. You can set up your groups, all the authentication and user groups, those are handled, and you can have collaborative space to share files and do your wikis and all of those things. So those are already taken care of. And what's really missing at the time that we were proposing is the geospatial data processing, data visualization, a lot of the capabilities of handling different formats, and especially building tools that involves geospatial data, involving maps, things like that, because for a lot of people, you ask them to go get a base map, and they would be totally at a loss. So we're going to try to make those things easy and help people build tools without doing a lot of programming. So all of that, this part that we're going to build it into HubZero, and that's our pretty much our project deliverable. Some just general stats about the project. That we're a 4-year project. We are in the 2nd year, and we just had our NSF review about 2 months ago, and we're moving forward, so that's good. And we do have a lot of information on this website if people are interested. So let's see. Now I'm going to go into a little bit of detail. Unfortunately, I don't really think I can go into the very detailed technical implementation, but we do have Lan and Rajesh here. If you're curious, feel free to ask them. So we're focusing on 3 areas. One is really the visualization, the mapping, and make that process really easy for people to use. And the second area is data management, and we're really focusing on allow people to contribute data online by themselves and then be able to share with people and be able to incorporate these viewing capabilities and link with the, whatever tools that people contribute. And meanwhile, we're also working with a number of scientific groups to build these use cases to demonstrate how these capabilities can be used. So I want to just highlight a few things, because there are a lot of things we're working on. A few things I thought might be more relevant to this group. So the first one is what we call Geographic Data Explorer. So it's not just about putting maps, not just about composing maps, but also how people can explore the data together with the context of maps and other geospatial references. So with this, I'd like to play 2 very short videos so I don't have to fumble and try to find my files. And let me see how I can do this from my screen. Oh, it doesn't let me launch it. Okay. Okay, I don't see what you're seeing there. Okay.
Well, it's on that screen.
Yeah. So.
Put a tab and hit the tab key so it's hidden.
Which key should I? Okay. Anyway. I'm going to do it the way I know how to do it. Okay, so this one is, I think I'm not doing the right order, but anyway. So this video shows that a tool running in the OpenBZ container that people can use remotely. And in this case, we're overlaying a Landsat image on top of this 3-dimensional display. And all these controls, these are widgets that people don't have to build themselves. They can eventually, when we release the software, these are just things they can use to compose their own tools. And there you have your typical control with the I want to move my cursor out of there. Okay, I don't know. Okay, so it's playing with the, sometimes you want to exaggerate the vertical dimension so you can see better. So there are all these controls built in, and you can move it around. And in this case, we're using a rendering server that uses what's called OSG Earth, that it's kind of similar to Google Earth, and it's public open source. And in this case, it's simulating light conditions. And depending on your data, if you have timestamps and if it indicates at night, and that data can be rendered with lighting. So it's still going. And you can zoom into the previously defined location. So these are quick things that we can do. And pretty obvious, West Lafayette isn't very interesting in terms of land formation. So that is one video that I wanted to show to so the other one is basically what I use to sort of suck in the data from Steve. And this is a very short video that just shows that, so rather, in addition to putting these point data, the locations on the map, you can actually go in the data itself and do all kinds of sorting, filtering, and filtering the things that you're really interested in, and then select those sites, and then view the data that's available for those sites. And these graphs and image libraries, all of those, they come in the data set. So for somebody who have the data sets in like CSV formats, and that's very easy to put in, so they don't need to do any programming. In this case, with the pictures, it actually has a couple of CSVs. And this is another example with weather and climate data that's come from 4 different sources. So this one is takes a little more to set up because it has multiple CSV files linked together. And this is an example that it's time series data, and we're using the average or some interpolated data to show sort of what they call heat map. You can just play on. So what I'm showing with these is that these are the type of capabilities that we've seen as needs people ask us to do. In the past, when we integrate these type of data sets, it can take up to months for a graduate student or a staff member to kind of work and put them online and decide how they want to organize the data. And then, sometimes the file system changes and you have to, redo a lot of that. And what we're building is to build this into what we call building blocks, data services, widgets, that's related to geospatial data and visualization. So when people come to use it, they can compose what they want to see as what we call a tool or a view, and then share that with the rest of the community. So hopefully that gives you some idea of what we're trying to build. Okay, let's see what I have next. And so the builder, the GeoBuilder, that's what we call the builder right now. It's one tool that we take in CSV files. Now, everybody knows that CSV files can be very, very tricky. And how do we deal with that? And so we're still working on that. We're also looking at how other people do it and try to learn from a lot of people. So this is one area that we're not going to ever be perfect and just take any arbitrary CSV files, but we're trying to work with communities and see, kind of where people converge. If we can make 80% of these data sets very easily imported, then I think it's people always talk about 80-20 rules. And if you can solve 80% of the data, make them easy to import, then I think it'll be great. So those are some of the things we're working on. From an architecture standpoint, if you look at the HubZero architecture, these are the things that's already there that were connected to high-performance computing resources and other type of resources. We're dealing with storage, where we have a framework for rapid tool development. Now, what we're adding is really the mapping component. What we call it mapping really covers the geospatial visualization aspects. And then we're adding the rendering server. And we're also looking at, in long term, looking at local graphics processing acceleration based on some of the new hardware that are going to come out. And also the linking the data support for that. So that's kind of the overall architecture. And then for large data, we're dealing with more and more large data sets. And we're Globus Online is one of the things we're using, and we're also considering other technologies to use to move large amounts of data. So on the data side, so this is, I won't go into this very much because that's part of our hands-on thing, so you get to see it for real in your browser. So just highlight a couple of things. So for data management, we're using this concept of data set. a data set can contain many files or folders, and so you can go in and create your own hierarchy. And depending on the type of file formats, that you can view them in different ways. For geospatial data, you can see shape files or raster. And you can also search within the data interface. You can search on the map. And we're also creating data service APIs. So for tools for somebody who comes and develop tools, they can actually access data that other people contributed. And so rather than moving things in and out of your local laptop, you can just do these things online. And I list microservices here. That's what we use with respect to iRods, that those services automatically extract the metadata elements to import, which we'll see when we do the hands-on. And data publishing. So more and more people are doing these online publishing, and HubZero has built in a data publishing or publication process. So basically, you can publish anything, any content, and you can request for a DOI. So all those capabilities are built in. And so we're adding the capability of not only you can publish your data sets, you can also add whatever viewers you want to put in there. Now, we're not exactly there right now. We can put in something similar to this. So if you put in a geospatial raster data set, and when people find this data set, they can take a look at, oh, this is, what you can actually explore a little bit, not extensively. So this is what we see as the future of publication, that you have DOI for people to cite it, and people can also look at what the data set represents. A few words about the data architecture. So there's the key, the central component of the iData, we call it iData, and the view part really provides the user interface and the logic and the application interface. And the data management really interact with the HubZero database, which manages users, groups, so that's how sharing is enabled. And it can also allow the tools hosted on the HubZero platform to interact with the data sets. And the mapping component can also be used to support other HubZero features. And here we point out that right now we're utilizing a lot of these technologies. And I think it's a challenge for us to be able to, one, package things very nicely so people can actually replicate and install this. And also, how do we keep up with other people's release schedules and all those things? Those are challenges we're trying to work with. Let's see. So I'd like to say a few things about the communities we're engaging. So we do have hydrologists and agriculture economists on our team. So they are providing use cases, and they're working with us very closely. So the way we work is the development process is pretty transparent, that as we have things ready, we push it on our website, and so they're there to use. We're just not widely advertising it because we can't possibly support if there are, thousands of people who want to use it. However, we are open for people to try it, so anyone who's brave enough to try it, we would love to work with them. And we work with our co-PIs from science domains very closely to develop tools. And in that process, we bring in new requirements and try to implement them and flesh out issues in our design. So, for example, in the hydrologic applications, we're really supporting modeling and data sharing. So in that particular case, the data they want to share is not just a file. It's what they call an input model, which models the entire watershed, and or maybe even larger scale. I don't really understand how they go about it, but so all I know is it's a pretty big zip file of thousands of files, and they want to be able to share those, and so people don't need to repeat the same amount of work just to create an input model. And then, of course, they want to visualize the output very quickly. So we're working with them through a tool called SWOT-Share. And with the economic analysis applications, there we're really dealing with global scale spatial data, and also the challenge of people in that domain. Typically, they're not programmers. They stay away from those things, and so even for example, one application we work with was there's large archive of crop modeling outputs that this what's the I forgot the program that generated with a lot of modelers who work together and generate the data archive. And so for a lot of for the modelers, they put the archive together. They say, okay, you guys, you can access it free, Globus Online, but still not very many people know how to do that. How do I get at the data? So if you dive in, you have to go in, many layers to see the actual file. And once you get it, it's NetCDF. I'm sure this group is comfortable with it, but the group that we're working with, they're not. So what we did was really to integrate large-scale data transfer underneath so they don't see anything, how the data get there, and then doing aggregation online so they get the data exactly what they wanted, and then doing their analysis from that point. So that really speeds up their entire process of acquiring data and doing analysis and publishing results. So I'm going to skip a lot of these things. So one thing I'll bring up, since Mike's here, we just started working with Mike to see what we can do for the weather community. And so, okay, I'm going to have to struggle with this again. Okay. All right, so what I like to do is bring up, where's my, so this is an application that we're prototyping. We're trying to flesh out some of the components that we need to build into our GAPS project to serve the larger community. So this is one driver that could feed us some information about what's really helpful. So in this case, we created a prototype that shows that we're pulling in data from, I guess I should go back to my slides a little bit. So this is a prototype that we built to allow people to explore the weather information, winter weather information that we got from Mike. And so you can see that there's some elements for selection. And what we're really doing is to select a region, and this is where we live. That's what Mike always looked at. And specify a date range. So in this case, we selected the sum of all the days. I think it's last December. So knowing that there were a lot of snow, so I was selected snow hours, and you can see the scale here, how many hours in total, and this is our area, Indiana. So then I thought maybe we should look at Northeast, and so it just astounded me that, this number that we're seeing, it's like 400 some hours. Can't see quite well. Yeah, so the whole, the data for the whole nation is available there. And we were actually talking about whether we should trim down and try to see if we can speed up the search, but it's kind of interesting to be able to compare and see. And so behind the scene, what we have is the data from NLDAS, and then additional processing to generate those winter indices, and including some of these acronyms. I have no clue what they're about, but I love the snow hours. And so more detail, we're dealing with hourly model output. They came in script files, GRIP files, and we store them in a MySQL database. We're using something, I think, newer than your traditional SQL. It's sharded. My understanding is it's a way to kind of scale up the database and split the tables into multiple, so you can have tables on multiple servers, that way to speed up the performance. And we created REST interface for data access, so you can build your own applications by connecting to the database. And so right now we're kind of testing with date ranges and selecting variables and aggregation and those things. And we also want to be able to plot. So if you mouse over to a location, be able to get the time series plot. And so how does this tie in with our project? So we're trying to see what we can do with multidimensional spatial and temporal data. And it's challenging, but can we do enough to capture what a lot of people need? So that's something we're trying to flesh out. And having this maybe a guided process for people to ingest the data and create their own analysis tools. So I was going to do live, but we can do it later in the hands-on session. So I want to say a little bit about how do we disseminate. I mentioned that we have a website, which we'll go to in a little bit. And we're really utilizing a lot of the built-in functionalities of HubZero. So for example, we're having those things installed with a very nicely structured software deployment process, so all our developers can work in parallel and push the changes out. We do it on a weekly basis, so if we have fixes or new features, they're out there pretty fast. And we also use the ticket system extensively among ourselves and also among with the users. So we can, anything we push out, if people are using it and they see problems, they usually contact us through the ticket system, and it also helps us to collect feedback and make changes to our design. And it's free to sign up. Many of you, I heard from our admin that many of you signed up for an account, so that's great. And we're also having a lot of training materials online, either directly off the HubZero website or with individual tools. And I can pull up a few and show you where those things are. And so the website is also connected to some pretty powerful high-performance computing systems that you can run computationally intensive simulations. And we're adding the data capacity as well. Okay, and some of the charts just showing the user base is growing, and we're hoping that once we release our really the builder type of software, that many more people will try it and use that to bring their data sort of live interactively. Some of the future things that we're looking at, as I mentioned, that we're investigating this HP Moonshot platform that apparently is lower cost, it's higher density, it consumes less energy. You can plug in a lot of these GPU cards in there. So we're looking into whether we can use that for the web server, so you can actually, so some of our applications right now, they're completely software rendered, rendering the graphics, and then other tools are using our render server, so that's another handoff connecting to the backend render server. And this is another option that we're looking at, whether it's going to really change the performance. And HubZero is open source, so you can download the source code, or you can download VMware images. And now we're just releasing the Amazon images on Amazon's marketplace. I don't know exactly because I haven't been there, so probably marketplace, and have it run there on Amazon. There's actually a company, private company, that provides services helping people create new images and run them with respect to HubZero. And there is the annual meeting that we, this year, we're going to be, several is going to be there giving presentations about work related to HubZero. So with that, any questions?